All right, in this lesson we are going to do dreaded arithmetic and geometric sequence and series word problems. It really isn't that bad. The tricky part is to figuring out which term number each problem is, and I will kind of lead that through you. Quick little joke to get you going. Hit pause if you want to read it. All right, here are all the formulas, all on one little slide here. They're on your notes, so make sure you refer to them as we get to them. And these are the ones we will be choosing from as we do this, okay? Here's our first problem. A woman made $35,000 during her first year of her job. Each year after that, she received a 10% raise, and kind of a two-part question here. First of all, how much did she earn in her 10th year on the job? And then the second question, what were her total earnings during the first 10 years? So if we kind of think about this first question, what I know is on the first year of her job, she made $35,000. Okay, so I want you to think about this. This means that year one was term one. Then I could give her a 10% raise, and if she got a 10% raise, that means she added $3,500 onto that. 10% of 3,500 is, or 35,000 is 3,500. So if I add 3,500 to that, and you don't need to do this, this is just extra, but if I added 3,500 onto that, the next year she would make $38,500. And again, this is year two, which equals term two. Okay, so if I want to know how much money she made in the 10th year on her job, I hope you can figure out first year, first term, second year, second term, third year, third term. The 10th year will be the 10th term. That's what I'm asking you to figure out, okay? If she's receiving a 10% raise, to get that 10%, you're multiplying $35,000 to that 10%, or you're multiplying 10% to that $35,000. So since you're multiplying, this is a geometric sequence, and to answer this question, I'm basically asking you to find the 10th term of a geometric sequence. And so this is the formula you will use. I know it's maybe a little bit small, but at least you can see the position it's in on your notes, okay? So to do part A, we will take that formula right there, an equals a1 times r to the n minus 1. Again, the first term is $35,000. Your ratio, be careful, you want her salary to grow, so you're not going to multiply it by 0.10, you're going to multiply it by 1.10. The 1 will give you the $35,000 back again, and then of course the 0.10 gives you that 10% raise. And then I'm figuring out the 10th term, and I should have put 10 in here. A10, the 10th term, is $35,000 times 1.10 to the 10 minus 1. Okay? 10 minus 1, sorry, I'm doing that in my head already, which is the 9th power. So to figure this out, you're going to go to your calculator, you'll put in $35,000 times 1.10 to the 9th. Make sure that you do 1.10 to the 9th first and then multiply by $35,000, or you put it in as you see it on your calculator, but don't take $35,000 times 1.10, get an answer, and then take that to the 9th power. That will give you the wrong answer. But you will get $85,528.17. It's money, so let's round it off to the nearest penny here. Okay, so there's part A. Then in part B, I'm asking you to figure out what were her total earnings during her first 10 years. So total earnings would tell me that you want me to sum up. So, and during her first 10 years, I want you to sum the first 10 terms. Okay? So to do that, you can do that a couple of different ways. Again, this is geometric sequence. So we could do it with sigma if we wanted. Sum up our first 10 terms. So I'm going from the first term to the 10th term. I will use this formula right here, right now. My first term is 35,000. My ratio, and I know you're going to think it's 10%, but remember you have to use 1.10%, 1.10, so that you get the what you started with back plus the raise to the n minus 1. So you could do that, and then you could stick it into your calculator. Or you could use this formula right here. And if you chose to use that formula, then you would plug in the first term is 35,000. 1 minus your ratio again is 1.10 to the 10th power. all over 1 minus 1.10. Okay? Either way you do that, when you simplify that and you get that into your calculators, you should get $557,809.87. So I want you to hit pause and actually practice getting those in and making sure that your answer matches mine. Okay? In the next one, you're talking about a piece of machinery that started at $80,000 and it depreciates $8,000 the first year, then $7,500, then $7,000, and so on. How much did the car depreciate during the 8th year? Okay, so here's what I wanted you to think about. The first year, because you have to be really careful about tricky number or term numbers. The first year is 8,000. Notice that's the first term. Second year, it was 7,500. Third year, it was 7,000. And I'm not going to make you, or let you, use a list, I should say, because I know you're only figuring out the 8th year here. So it would be really easy to list 8 numbers, but that's not what I want you to do. I want you to figure out the 8th term in this case. Notice this $80,000 is really not needed at all. Okay, I don't need that $80,000. I am just trying to figure out how much it depreciates, so that's all I care about in this case. First of all, you have to figure out, is this an arithmetic or a geometric sequence? And you're subtracting $500 each time, and because you're adding or subtracting, then it's an arithmetic sequence. So this is an arithmetic sequence where I want you to figure out the 8th term. So we will use that formula right there. And to do that, then I'm just going to rewrite that formula so that it's a little bit bigger. So the 8th term is the first term. 8 is 1. My constant difference, I'm subtracting 500, so make sure you put negative 500 in there. So when I simplify that, I should get $4,500. Okay? If I had time, or if I wanted to take the time, I might ask you, what is the machinery worth after 8 years? If I asked you what the machinery was worth after 8 years, you would want to take that $80,000, right? And then subtract 8,000, subtract 7,500, subtract 7,000. And if I asked you what it was worth after 8 years, I would basically sum up the first 8 terms. I don't know why I'm writing this. Sum up the first 8 terms and subtract it from 80,000. So that is something what I could do. I'm going to just answer, I'm going to write this question as, what is it worth after 8 years? I'm not going to take the time to do that here, but I'm just telling you, if I wanted you to know what was it worth after 8 years, you would sum up the first 8 terms and subtract it from the initial investment, which is $80,000. Okay? All right. Here we go. Carp hears about KDUZ giving away Twins tickets and comes up with a giveaway of its own. Carp is going to give away $106.90 in cash on the first day and $1,229.35 on the last day, adding the same dollar amount each day to the previous day's prize money for a total of $70,821.25. How much will it give away on the second and the third day? So if you kind of think about what's happening, here's what's happening. On the first day, they give away $106,090. In the end, I need to know what's going on the second day and what's going on the third day. I don't know that. Got to figure that out. But I know that if I add a bunch of terms on here on the last day, which I don't even know what term number that is, I know on the last day they give away $70,821.25. That's all I know. Okay. So, keyword in here, they say that they're adding the same dollar amount each day. And so because they're adding, we know we're dealing with an arithmetic sequence. Okay. What I also know is I know that I have a total. This is my total. Oops, sorry, I wrote this wrong. That's not what they gave away on the last day. They gave away $1,229.35 on the last day. Sorry about that. Anyway, the total the amount that they gave away when I take the 106.90 plus the next term plus the next term plus the next term plus the next term, however many terms I need to add up, and the last term, which is $1,229.35, then I get this total right here. Okay? So what I have is a sum, and what I'm probably going to need to do then is use one of these two sum formulas right here. We did not talk about this formula the other day when we did this. We only used the one on the right. And if we use the one on the right, the problem is that I can use the one on the right, but I don't know how many term numbers there are. Okay, so since I don't know that, it might be easier to figure out how to solve that. Okay, so I am actually going to use this formula right here in this case. Okay, I'm going to use the one on the left this time. So what I know is the grand total is $70,821.25. I don't know how many terms there are. I know that the first term is 70,820, no. Yeah, I know that the first term is not that. I know that the first term is $106.90, sorry. I know that, and actually, I'm lying to you. I'm not using that formula. I'm using this one, aren't I? Okay, I'm using that one. The first term is $106.90. It starts off the same way, so we're all good. And then the last term that you're going to add is $1,229.35. And then I will divide that by 2. Okay, so I don't know what that term number is, and all I can do is use this formula because that's all I've got. And then once I figure out n, I can maybe kind of go from there and figure some other things out. Okay, so I'm going to multiply by 2. That will drop. And when I do that, I get $141,642.50. And when I add 106.90 and $1,229.35, I get $1,336.25, which of course I will then divide by that. And when I do that, I get n equals 106. So all I know now is that this is the 106th day of the giveaway. Okay? But that still doesn't tell me how much I'm adding each day. Okay? It still doesn't tell me what do I need to add to get to the second term, to get to the third term, to get the whatever. So now I'm going to go back and I'm going to use this formula. Okay? My AN is $1,229.35 and my N is 106. Okay? My N, and this is really A106, which is also AN in this case. Okay, so I'm using this formula now. Again, what you want to plug in here is the value that's plugged into a certain spot on your thing. So I know that the last term is $1,229.35. And I know that the first term is 106.90. And I know that this number right here is in the 106th spot. So I can put 106 in for n and then solve that for d. So $1,229.35 equals 106.90 plus 105d. And I will subtract 106.90. And I will get $1,122.45 equals 105D. Divide by 105. And D comes out to be $10.69. So what they're adding on each day is $10.69. So since I know that day 1 is 106.90, I know that to get to day 2, I will take that 106.90 and I will add 1069 to it, and I'll get $117.59. And then to get to day 3, I will take that $117.59 and add 1069 to it, and I'll get $128.28. So that was a lot of work to figure that out. All right, this one's kind of a tricky one here. Term numbers are really tricky on this one. A rubber ball dropped on a hard surface takes a sequence of vertical bounces. With each bounce, the ball loses 2/7 of its preceding height. This is, you got to pay close attention. If it loses 2/7, that's not what you really care about. What you really care about is how much it retains. And if it loses 2/7, then it retains 5/7 of its previous bounce, okay? And that's the piece that you really care about, is that it retains 5/7. The ball is dropped from a height of 21 feet. I am going to draw a picture that will help us with part A and part B, okay? So here's what I want you to think about. Here is the initial height of the ball, right here, okay? It's 21 feet off the ground. So I want you to think about this. It falls, okay? And so we know that this distance right here is 21. And I'm going to say that A1 is 21. Okay? Right here is when it has its first bounce. And then it comes back up. And you know it never comes back up as far. It only comes back up 5/7 of the height it was at. So it comes back up. And then this distance right here is A2. And I don't know what it is. I don't care what it is. I could figure it out if I wanted by taking 5/7 of 21. Okay? But it reaches a height. It comes back down. This is the second bounce now. It comes back up to 5/7. It comes back down. So this is A3 right here. Comes back down, makes a third bounce. Comes back up 5/7 as much. So this is A4. Comes back down. This is now the fourth bounce. Again, comes 5/7 of the way up. This is A5. And then it comes back down again. And this is where it hits the ground the 5th time. Okay, so I'm going to use this picture. So here's the question. Part A, what height does it reach after the 4th bounce? So part A, after the fourth bounce, it bounces and comes back up. This is what I'm really talking about right here, till I figure out, so that I can figure out what height it reaches after the 4th bounce. Okay, so it's going to come down after the first bounce, down after the second bounce, down after the third bounce, down after the 4th bounce, would be this term right here. Notice it's actually the 5th term. Okay, so I really and truly want to find the 5th term in part A. So when I do that, then I am going to do, first of all, it's a geometric sequence. You're multiplying by 5/7 every time. So I will use this formula. I'm wanting to find the 5th term. My first term is 21. My ratio is 5/7 to the 5 minus 1. And you get about 5.47 feet when you plug that into your calculator. Okay? Then in part B it's wanting you to find the total distance traveled when the ball hits the ground for the 5th time. Okay, this is tricky now. Ready? First of all, you have this distance. Okay, that stands alone at 21. Then you have this and back down again. So do you see how you have this twice? You have the first term once and the second term once and twice. The third term once and twice. The 4th term once and twice. The 5th term once and twice. So to figure out part B, this is a little tricky. To figure out part B, you're actually going to take 21 plus 2 times the sum of A2 to A5. Okay, Again, the 21 comes from right here, and then this is the second term, but it goes up and down that same distance, so you have to add it twice. The third term goes up and down, so you have to add it twice. The fourth term, but this first term, this 21, it only goes down that far. It never comes back up 21 feet, it only goes down that far. So you don't want to really worry about that. Okay, so I'm going to take 21 plus 2 times the sum of the second term to the fifth term of the geometric sequence where the first term is 1, my common ratio is 5/7 to the n minus 1, like that. Okay, and I don't know, you can plug all that into your calculator. Plug the sigma part in, multiply your answer by 2, add 21 to it, and you should get about 98.67 feet when you plug that all in. Okay? Tricky. All right, this time KWZ is planning to give away 1,425 tickets in the month of June. The station wants to increase the number of tickets given away each day by 3. How many should the station give away the very first day? Okay, the very first day. So the problem is I'm trying to solve for n, and all I know, the only thing I know, is that they gave a total of 1,425 tickets away, and that's it. Okay, I don't know what they gave away the first day. I know that this tells me, and by the way, the station wants to increase the number of tickets given away each day by 3. If you're increasing by 3, by 3, by 3, by 3, plus 3, plus 3, plus 3, plus 3, you're adding, so it's an arithmetic sequence. Okay, I have the total here, so I know I'm going to have to use sum. I will use one of these two formulas. If I choose to use the one on the right, then I need to know n, which I do, and it doesn't give it to me directly, but I'm doing it every single day in the month of June. And the month of June has 30 days to it. If you didn't know that, it's assuming you did. So there are 30 giveaways that are happening here. So n is 30. Okay? But if I choose to use the problem or the sum formula on the right, then I need to know what the first term is. I know that n is 30. I would need to know the first term, which is what I'm needing to find. I don't know that. But I would also need to know how many tickets are being given away on the 30th day. And I don't know how many tickets are being given away on the 30th day. So this formula is not going to help me much. I'm actually going to use this one right here, and I'm going to rewrite it a little bit bigger so that we can focus on that. If I choose to use this formula now, I don't need to know how many tickets were given away on the 30th day. Okay? But I know that the sum is $1,425. I know that there are 30 days in June, so there will be 30 giveaways. I know that on the first day, that's what I'm trying to figure out. I don't know how many tickets are going to be given away on the first day. I know that n is 30. I know that I'm increasing my number of tickets by 3 tickets each day. And then, of course, I will divide by 2. And at this point now, once you have this, all it takes is to do some simplifying. Okay, so I will multiply both sides by 2 so that I can get rid of my fraction. And then I'll have 2850 equals 30 times 2a1 plus 87. I will divide by 30. 95 equals 2 times a1 plus 87. Subtract 87. And 8 equals 2 times a1. Divide by 2. And a1 equals 4. So there should be 4 tickets given away on the first day so that I can increase my number of tickets by 3 each day and give a total of 1,425 twins tickets away. All right, now these are some recursive formulas. They look like they are story problems, but they are recursive formulas, and so you have to kind of really just know how to read them, which is sort of the trickiest part. Okay, So I am telling you in this case that A0 is 100. If you read through there, it says that it talks about starting with 100 bacteria in a container, and they're finding the number of bacteria present at any given time using this formula. And this is key to pay attention to. N is the number of hours after the beginning of the experiment. So I know at the beginning of the experiment there's 100 bacteria. And then I want to know after 1 hour, after 2 hours, after 3 hours, what's happening. Okay? So my question in this case is how many bacteria are present after 5 hours of the experiment. Okay? So since N is the number of hours after the experiment, since I'm looking at how many bacteria there are after 5 hours, basically what I'm asking you to do there is to find A5. So when I use this formula right here, I want to find A5. And in order to find A5, this is what has to happen, which is the same as 2 times A4. Okay? Here's what this is saying. This formula is saying to find the term number you need, you are going to take 2 times, if this is n and this is n minus 1, n minus 1 would be the term before it. That's what it means, is the term before it. So I'll say this again. To find the 5th term, you're going to take 2 times the term before it, or 2 times the 4th term. That's what that means. To find the 5th term, you're going to take 2 times the term before it, or 2 times the 4th term. Here's the problem. I don't know the 4th term. So let's find it. So to find the 4th term, I would take 2 times the term before it, or 2 times the 3rd term. Don't know the 3rd term. So let's find the 3rd term. To find the 3rd term, I would take 2 times the term before it, or 2 times the 2nd term. Again, I don't know the 2nd term. So let's find the 2nd term. To find the 2nd term, I will take 2 times the term before it, or 2 times the 1st term. Don't know the 1st term. So to find the 1st term, I will take 2 times the term before it, which now I know that. Okay? So I know that A0 is 100. So I can take 2 times 100, or of course get 200. And then I will plug that in right here. Since I know the 1st term is 200, I can take 2 times 200 and get 400. Okay, now I know that the 2nd term is 400, so I can plug that in and go 2 times 400 is 800. Now I know that. I can plug it in. 2 times 800. Do you see what's happening every single time? You're taking 2 times the term before it. Okay, that's all you're doing. So this time I get 1600. This is the long way. I don't want you actually to do this the long way. I want you to not have to write all this out. But I'll plug that in right there. And 2 times 1600 then is 3200. Okay, I want you to be able to read this notation and realize to find the term you need, you take 2 times the term before it. Okay, so to find term 1, I would take 2 times the term before it. To find term 2, I would take 2 times the term before it. Okay, that's all this is telling you to do. Okay, and the next one now, the notation is this. This means to find the next term, because it's n plus 1, I take the term I have and I subtract 6. Okay, that's what that means. To find the next term, that's what n plus 1 is, I take the term I'm on, I multiply it by 3, and I subtract 6. Okay, so here we go. To find A2, I take 3 times A1, okay, and I subtract 6. Okay, so that's what I'm doing to find it. So I'm at 4. Okay, this formula is saying take 3 times the term you have and subtract 6. So in this case, 3 times 4 is 12. Subtract 6, I get 6. Okay, the next term. 3 times 6 is 18. Minus 6, I would get 12. To get the next term, I take 3 times the term I have. So 3 times 12 is 36. Minus 6 is 30. To get the next term, I take 3 times the term I have, so 3 times 36 minus 6 would be 84. And there's the first 5 terms right there. Okay, and in the next one, I know the first term is 4, I know the second term is negative 3, and what this means now is to find 2 away from where you are. Okay, you take 1 away from where you are. I'm going to go the other way around. Okay, I'll actually go this way. You take where you are times 2, and you add the next term to it to find 2 terms from now. That's what that means. Okay, so I'll show you what this means. Here we go. If I take 2 times 1 term, okay, so in this case, to find this spot right here, I would take 2 times 4 and add the next term to it, which is negative 3. Okay, to find that spot right there, I took 2 times 4, add the next term to it, which is negative 3, and I got 5. Okay, to find this spot right here, I would take 2 times negative 3, add the next term to it, which is 5. So 2 times negative 3 is negative 6, plus 5 is negative 1. Then to find this term, I will take 2 times 5 and add the next term to it. So 2 times 5 is 10, plus negative 1 is 9. Okay, and you would keep going. So to find 2 terms away, you take the one before it plus 2 times 2 before it, basically is what's going on there, whichever way you want to think about it. Okay, but that is your lesson for today.